So you see the graph here, the transfer characteristics graph. We are going to apply the different values, and I'm going to find the values of constant. So when omega t equal to 0, when omega t equal to 0, put 0 in this equation. So IC will be equal to IC plus B0 plus B1 plus B2, because cos 0 is going to be 1. And it is going to be the maximum. So I'm going to have IC max. When omega t equal to 90, when omega t is 90, cos 90 will be 0 and cos 180 will be -1. So see, from the graph, I'm taking all the values and I'm writing here. When omega t equal to pi by 2, IC is equal to capital IC. When omega t equal to pi, IC equal to I minimum. So therefore, from this relation, I am going to, these values are got from graph, and I am going to substitute these values in the equation and find the values for B0, B1 and B2. Okay, so substitute these values in the equation. Omega t equal to 0. When you put omega t equal to 0, IC plus B0 plus B1 plus B2 equal to capital IC. Okay, so same way you substitute all the parameters, omega t equal to 90, omega t equal to 180, and you will get the values for B0, B1 and B2. So B0 is going to be equal to B2, B1 is going to be I max minus I min by 2, and B2 is going to be I max plus I min minus IC by 4. B0 and B2 are same, so these two values will be same. So these graphs are, these values are got from the transfer characteristics of your transistor. So from this, I need only second harmonic distortion. So B2 is the required term. So I can write D2 is equal to mod B2 by mod B1. B2 is what is the power present in 2 omega t. Okay, and B1 is my useful power. P1 is what is the power present in omega t. So our reference is going to be the fundamental frequency. So we'll compute everything with respect to B1. So D2 equal to mod B2 by mod B1 into 100%. So if you take IC is equal to I max plus, if you take the value of the collector current to be average of maximum and minimum values, then your values of B1 and B2, B0 and B2 will be 0. So you can say there is no distortion in your system. Okay, so the one simple way to eliminate distortion is take the value of collector current as maximum average value of maximum and minimum value of current. So if you take that, you can ensure that second order distortion is going to be completely eliminated. See, don't think only second order distortion will be there. In this case, we have considered the amplifier with second order distortion terms only. If you want to have third order term, what will be the additional term you will be adding to the collector current? Can anybody say? What will be the additional term we will be adding to this equation if we are going to find a third order harmonic distortion? What additional term we will be adding to this equation? It is going to be K3 into IB cube if you are going to find out the third order harmonic distortion. Same procedure, you expand everything, eliminate, find, you will be having BIC, B0, B1, B2, B3. So additionally, you will be finding what is the B3. So the third order harmonic distortion will be D3 is equal to B3 by B1 into 100%. That is going to be your how much percentage of third order harmonic distortion you are going to have in your signal. Ideally speaking, all these harmonics have to be eliminated. Ideally, they should be 0. But practically, how much ever you filter out these harmonic signals, you cannot make them completely 0. But ensure that at any point of them, they are as minimum as possible. Okay, that is going to be your second order harmonic distortion. And you are going to compare the values what you get from the graph and the values what you get from the equation. By that, you can find the value of constants B0, B1 and B2. Okay.